I'm Luca Congedo and you're watching from QGIS to Remote Sensing. This is the first basic tutorial about the semi-automatic classification plugin and the classification of land cover. We are going to classify a Landsat 8 image. In particular, we are going to identify 4 types of land cover: water, built-up, vegetation, and bare soil or low vegetation. The study area is Greenbelt in Maryland, USA, that is the site of the NASA's Goddard Space Flight Center that will lead the development of the future Landsat 9. So let's start the tutorial.
So let's start with a brief description of the land cover classification steps, from the definition of the land cover classes to the iterative phase of the algorithm training with the creation of ROIs, region of interest, with the photo interpretation, the assessment of spectral signatures separability and the classification preview, then the classification of the whole image, the refinement of the classification and the accuracy assessment. This is the interface of the new SCP version 6. Here we have the SCP doc. You can install the semi-automatic classification plugin from the menu Manage and Install Plugins. Here, once installed, you will have this dock with all these tools. This is the home of the SCP dock with this button that can open the main tools of the SCP interface. Here you can see the Landsat tool and all these tools for download, preprocessing, but we are going to see these later. This is the main toolbar with tools for RGB composites, regions of interest, and classification previews. And here we have the SCP menu with a list of all the tools. And of course you can drag and drop the interface as you wish. And you can place, for instance, the SCP dock here beside the layers panel. And after this brief introduction of the SCP interface, now we are going to download the image. Here we have the menu. So here the download products tools. Here we have the search parameters with the upper left and lower right coordinates. We can click this button and select in the map the coordinates, with a left click for the upper left and a right click for the lower right corner. As you can see, here we have the coordinates. However, we are going to enter here the coordinates manually. So here, for the upper left coordinates, we set -77 for the X, 39 for the Y, and for the lower right corner, -76.9 for the X and 38.9 for the Y. So here we have entered the search coordinates. Now we can select the product. We have all these products here in this list, from Sentinel-2 to Landsat images, Aster and MODIS products. Of course, remember to enter here your login user and password for these services. Of course, free registration in order to download the products. And now we are going to select Landsat 8, L8, here in this menu. And next we can set the range of dates. We can of course select from calendar, but we are going to set the dates manually. So here enter 2017 4/16. And the same date here. So we have set the range of dates. We could also set the maximum cloud cover percentage here and the maximum number of results of the search. Now we can click this button here, and after a few seconds we have the product list here, this product. This is the Landsat image, of course acquired in this date. Here in this table we have all the information such as path and row and other useful information. If we click this product in this list, the preview of the image is automatically downloaded and displayed here. So we can see, for instance, if there are clouds in the image. If we click this button here, we can load this preview directly in the QGIS map. So here we have the preview, of course a low resolution preview. Here you can see the image. And now we can select in the download options tab, we can select the bands. We can download only the bands that we are going to use for the classification. So here we are going to leave selected all these bands, and we are going to uncheck the band 1, band 8, band 9, 10, 11 that we are not going to use in this tutorial. So now we are going to download this image here in the product list. If this option preprocess images is checked, the image is automatically converted to reflectance, but I'm going to uncheck this now, and because of this option, only previewing layers, as you can see the preview is loaded in QGIS, we are going to download only the images that are loaded in QGIS. So now I can click Run, and now I can select the directory where I can save the Landsat bands. And as you can see, the download has started. After a few minutes, all the bands are downloaded and loaded in QGIS. Here, as you can see, all these bands with this name. I can, of course, remove the preview that we use for the download. And here we have the bands. Now we are going to clip the bands for our study area, so that we are going to classify just a small subset of this image. In the CP menu we can select the Bandset tab. Here you can see the main interface. We are going to create a bandset here for clipping. So now I'm clicking this button to refresh the single band list. Here we have the list of all the Landsat bands. I'm going to select all the bands except the quality assessment band that we are not going to use in this tutorial. Now I click this button to add the bands to the bandset 1. Here we have the list of bands in the bandset. And now I'm going to the preprocessing tools and select the Clip Multiple Rasters tab. Here, as you can see, the Select Input Bandset is set to 1, so that we are going to use this bandset 1 as input. Of course, I can create other bandsets using this button here. As you can see, I've added new empty bandsets that I can use for other processes. and I can click the X for closing the band set. So now we are going to clip this band set 1. We have also the option for the output name prefix. And we can select here the clip coordinates. We could, of course, click this button here, and then in the map, left click for the upper left and right click for the lower right point, defining the coordinates for clipping here. But in this case, we are going to enter manually the coordinates. So here I'm entering the coordinates for the upper left X and the upper left Y. And then the coordinates for the lower right point, the X coordinate and the Y coordinate. These coordinates are in the same projection as the images. Of course, I could use also a vector file for clipping. And here you can see the clipping region. Now that I've entered the coordinates, I'm clicking Run for selecting the output directory where the clipped bands are saved. Here, for instance, I'm creating a new directory, clip, selecting this, and all the clipped bands will be saved in this directory. Here, as you can see, the process has finished, and the clipped bands are loaded in QGIS. As you can see here, all these bands with a name starting with clip. Here, as you can see, the clipped bands, a very small subset for this tutorial. And I can remove these bands that we are not going to use in this tutorial. So now we are going to convert the bands to reflectance, the clipped bands here. Now we are going to select from the SCP menu the preprocessing tool Landsat, that is for the conversion of Landsat bands to reflectance. So here we can select the directory containing Landsat bands with this button here. Now I'm going to select the clip directory where we saved the clipped Landsat bands, and as you can see, the path is listed here. This message, this red message, informs that this required metadata file, the MTL file, is missing from this directory. So we can use this button here to select the MTL file. Here, this txt file, that is the metadata containing the required information for the conversion to reflectance of this band. This table is filled with this data here, and all this information that is used for the conversion of Landsat bands to reflectance. Also, we are going to apply the DOS1 atmospheric correction, a very simple image-based correction. We can check here this option, and as you can see in this graph, the DOS1 correction corrects the image band in comparison to the uncorrected values and the surface reflectance, as you can see, especially for the blue and the green band. So we are going to apply the DOS1 correction only to the blue and the green band. And then uncheck this option create band set, because we are going to create band set later for the classification. And now we click run for selecting the output directory. I'm now creating a new directory, reflectance, here, where all the converted bands are saved here. And the process starts. After the conversion, all the converted bands are loaded in QGIS. Here you can see the bands starting with the RT in the name. Here we have the clipped bands that we can now remove. Now we are going to define the band set in SCP. The band set is the main input of image bands. Here in the SCP menu, select band set. Now we click this button here to refresh the list of bands loaded in QGIS. I select all these bands converted to reflectance that I'm going to add to the band set 1. But first I'm going to click this button, reset, to remove the previous bands that we loaded for clipping the Landsat image. So now that I have removed the bands, I can click this button to add these bands, the converted to reflectance bands, to the band set 1. So this will be the input for the classification. Here in Quick Wavelength Settings I'm going to select the satellite. Here, as you can see, this long list of satellites. I select Landsat 8, and as you can see, the center wavelength is automatically defined. This is useful for the spectral signature. As you can see, also the wavelength unit here is defined. So now that we have defined the band set, we can hide these single bands. And using this tool in the SCP main toolbar, in the RGB color composite, we can select, for instance, 321 for creating a virtual band set that is a virtual color composite, an image, a color image that we can display in the QGIS map. And we can also change the color composite, for instance 432. This is a brief scheme of the color composite, which is the combination of visible colors and the spectral bands. If we click one of these buttons here, we can adjust the stretching automatically of the band set here. As you can see, we can display the image. And we can select the color composite from this menu. We can change the color composite for improving the photo interpretation. So here we can see the urban area, buildings, the roads, and the vegetation here in red. So now in the SCP doc, we are going to select the training input tab. We can create the training input file that is required for the collection of regions of interest. Here, clicking the training input, we can see this button here for creating a new training input file. If we click this button, we can select here a name for the training input, for instance training, and click save. So now we can collect the ROIs inside the image. So for the ROI creation, here all the ROIs that we are going to collect will be listed in this table here. We can see the difference between macro classes and classes, where the macro class is a set of length cover classes belonging to the same material. So here we can see the list of classes that we are going to classify in this tutorial. So we are going to create a first ROI for the water class. In the SCP toolbar we have this button here for drawing a polygon manually. and this button here for creating a polygon using region growing algorithm. So we can zoom here in this dark area. This is a lake, water. We can use this button to display better the stretching. And if we click this button here, you can see that in the map the NDVI value, that is a spectral index, is displayed in the map. So we can see here that water has very low or negative values. And now we can click with the left click, create a polygon here, and right click for closing the polygon. So now we can save the ROI polygon in the ROI signature list. But first we need to set the macroclass information, water, and the class information, for instance lake. And now we can click Save to save the ROI polygon in the ROI signature list. So now the ROI is saved in the signature list, and also the spectral signature is calculated. And we can see here the information, the macroclass, the class information lake, and the color that will be used for the classification. If we click here the macroclass list, we can see the first macroclass, water, that corresponds to the first ROI here, the lake, which belongs to the macroclass 1, water. And you can see that the class ID has automatically increased by 1. So we can now create a new ROI, for instance for the built-up class. So we can zoom, for instance here. We have this urban area, buildings. We can click this button to create a ROI using the region growing algorithm. We can see the NDVI value, very different between urban area and vegetation in red here, as you can see, with this false color composite. You can see here the option in the ROI options that this tool displaying DVI is activated. If we uncheck this, the value is not displayed. And if we check this again, we can see the NDVI values of the pixel below the cursor. So if we click here in any pixel, we can see the region growing algorithm. This is a scheme of the algorithm, so you can see that all the pixels with a spectral distance below a certain threshold are selected as a ROI. So if we zoom here, we can see a very small ROI. We need to increase the spectral distance here, so for instance 0.08. And I click again, and you can see the polygon is a bit larger. You can use this button here to show and hide the ROI. So now we can save this ROI, so we need to change the macroclass ID, and we need to set the macroclass information. So for instance here, we set built-up for this macroclass. And we'd also change the class information, for instance buildings, here. So we can click this button here to save the ROI in the ROI signature list. Here you can see the ROI polygon in black in the map, and the buildings ROI listed in the signature list. And we can also see the macroclass built up in the macroclass list. So now we can create another ROI for the third macroclass, vegetation. So we can zoom, for instance, in this part of the map here. We can see the vegetation displayed in red because of the RGB color composite. If we click this button here, we can create a ROI using the region growing algorithm. So you can see here the very large area. So probably we need to lower the value, the spectral distance value, for instance 0.05. You can see here that a lower number of pixels is selected now. We can decrease again 0.03 the spectral distance, and we can see a smaller ROI. So here we can see, so we can for instance save this ROI polygon and change the macroclass code, so tree, change the macroclass information, vegetation, and of course change the class information. The class ID was automatically increased by 1 when we saved the previous ROI. So we change the class information here, for instance trees, and we can click the save button here. So the ROI and the spectral signature is listed here, and also the macroclass vegetation is listed here. So now we can create the fourth ROI for the fourth macroclass, bare soil or low vegetation. We can see that in this area there is actually no bare soil, but actually it is low vegetation. You can see here the low NDVI value. So we can create a ROI here, for instance. We can see the ROI polygon here. So now we change the macroclass ID 4 and the macroclass information bare soil, and we change also the class information, so for instance low vegetation. So as you can see, the difference between low vegetation with a low NDVI value and high vegetation with a very high NDVI value. So we can click the save button, and the ROI polygon is saved in the ROI signature list, and the macroclass is saved in the macroclass list. So now that we have saved a few ROIs, we can assess these spectral signatures here. So for instance, we select with a click all these ROIs that are highlighted in blue, and we can click this button here to display the spectral signature plot. Here you can see the plot of each spectral signature: water, built up, vegetation, bare soil. We can show and hide each signature with this checkbox. So for instance, we can compare the built up and the bare soil spectral signatures. We can see that they are very similar. We can see the center line and the semi-transparent color that is the variance of the spectral signature for each band. So if we compare all these spectral signatures, we can also assess the spectral distance using this button here. So I click this button, and in the spectral distances we can see the combination of each pair of spectral signatures, where a set of spectral distance indices are calculated So we can see here, for instance, that the class trees has a very similar spectral angle to the class low vegetation. As you can see here, this value is highlighted in red. We can also display the spectral details here. For each spectral signatures, we can see a set of informations from the wavelength and values for each band, and the standard deviation of each band, and of course the count of the pixels of each ROI, region of interest. So now that we have assessed these spectral signatures, we need to create more ROIs for the land cover classification. So for instance, we can zoom here. We can change the RGB color composite from this menu. So we can select, for instance, 321 natural color, but we can also enter custom values for the RGB color composite. For instance, 346. This is very useful for highlighting urban area and bare soil. You can see here the difference between these color composites, and how these color composites highlight the spectral features of the pixels. We can also use this tool in the SCP main interface, the RGB list tool, that allows to manage the RGB color composites. You can see I created a few more ROIs that are saved in the training input file. And you can see here in the layers panel of QGIS, you can see that the training input is loaded as vector in the QGIS layer panel. You can see here I've created more ROIs. You can change the color composite here. So now we can create the classification previews. But before the classification, we need to change the colors of classes as we like. So for instance, we can change the color for the lake, the blue, and click OK. We can change also the color for buildings. For instance, red. And so on for all the other spectral signatures. We can also change the color in the macro class list, the color of macro classes. So if we use the macro class, then the classification will use these colors. We can change the color for the water macro class, for instance blue, and so on. So once we have set all the colors, we can go to the classification tab here. We can select the classification algorithm. We have here this list. We can choose between minimum distance, maximum likelihood, and spectral angle mapping. So in this case, we are going to use the maximum likelihood algorithm. Of course, please refer to the user manual for the specifications of each algorithm. And now we can use this button here to activate the pointer for the classification preview. We can now click in any point of the map, and as you can see here, a square is created, a classification preview, using all these spectral signatures. And of course, you can notice that we have used the class ID. So this classification preview used the class ID. If we choose the macro class ID, then we are going to use the macro classes. And as you can see here, the colors of the macro classes are displayed. We can change, for instance, here the size parameter of the classification preview. If we click this button, we are going to create a preview in the same point. As you can see, the preview is larger. We can see here the classes, the land cover classes. We can use this tool to change the transparency of the classification preview, so we can see also the image below the classification. And we can assess the correspondence of the pixels, the classification, to the image. And we can decide if we are satisfied with the classification results or we are going to create other rows. Here I'm going to choose to use the class ID. Here you can see the difference. Selecting the class ID is useful for assessing each individual contribution of the spectral signatures for the classification. So for instance, we can decide to remove one of these spectral signatures that maybe can create classification errors. So if we click here this button, so we can see here the difference with another classification preview. Now that we have created all these rows and we have assessed the spectral signatures and the classification previews, we can create the final land cover classification using all the spectral signatures. So we can choose here to use the macro class ID. The algorithm is already defined. So we can click this button here, Run. If we click this button, we can choose the output file of the classification, setting the classification name. And we click Save, and the classification process will start for the classification of the whole image. Here, as you can see, the result of the classification is loaded in QGIS. Here, the classification raster with the legend. We can see the colors corresponding to each class. We can see here, for instance, we can see, of course, that there are a lot of errors, classification errors. For instance, we have here these pixels classified as built up. We can see other possible errors of classification here. So probably for better results we should collect more spectral signatures in order to remove these classification errors.
Well done! We have completed our first land cover classification of a Landsat image. I'm going to write other tutorials about the use of the semi-automatic classification plugin and other case studies. Please remember that you can refer to the user manual. Also, for any comments or questions, please join the Facebook group or the Google Plus community. Also remember that you can contribute to the development of the semi-automatic classification plugin and the translation of the user manual. Thank you for watching.